Arctic Vortex 2021. You're cold, they're cold too, so we're gonna go inside and do a new thing. I was thinking about rebuilding my jackhammer today, but something about stabbing yourself in the hand with an O-ring pick when your hands are frozen cold like little meat-flavored popsicles, it just makes it hurt that much more. Loading up the graphics animation software, and today we got us a little bit of book learning. My good buddy Honey Badger went through great lengths in order to get me this for Christmas, because I'm one of those weirdos that asks for textbooks for Christmas. To all of you valedictorian smarty pants people that always sat in the front of the class, this video ain't for you. I have a particularly ingrained hatred for any form of authority whatsoever, so school wasn't really my bag. There are too many damn videos on the internet if you're trying to learn electricity to go like this. Hi, I'm Smarty Pants. Welcome to my channel. Today we're going to look at how electricity works. Here we have a battery, and when we connect a light bulb to that battery, it turns on. Knowing how this works, we can take a look at this simple circuit. See this particular segment of the circuit right here? This is called a fuckulator. Fuckulators obfuscate magnetoreluctance in units called delta mu. Electron fuckulation can be easily calculated with Fermat's theorem of dissimilar gradients. Electron fuckulators are integral to the operation of common everyday objects, such as Irving-bearing capacitor manifolds, reciprocating Marsal-Vane cooling, eggs Benedict, semilunar cardinal gram meters. We can make a fuckulator at home with some aluminum foil, a glue stick, a plastic rhinoceros, and some oyster sauce. Don't forget to smash that like button. Don't forget to hit that bell so that your phone has another reason to go ding right in the middle of a board meeting because I uploaded another video of uncomprehendable math garbage. And don't forget to check out my sponsor at BoardVPN. VPNs allow you to steal people's Netflix account from all the way across the globe. And also, it'll keep the government from knowing that you're using Bitcoin to buy illegal whale semen. I honestly do not understand how anybody would expect anyone to learn anything from a format like that. Definitely not me. So we're gonna tiptoe on into this complicated looking stuff with yours truly. This may seem horrifyingly complicated. And when things look horrifyingly complicated, we have to sing the song of our people. I am nothing but a squishy meat bag on a rock flying around the sun. But the people that wrote this book, they are also squishy meat bags. My brain and their brains are made out of the same vitamins and mashed potatoes. If they can understand it, I can understand it too. What one man can do, another can do. What one man can do, another can do. Good, because today, I'm gonna kill that motherfucker. And since I just got my paycheck, we can actually splurge on this video being directed by Stanley Kubrick and even have a guest narrator. My name is Morgan Freeman, and today we will explore the complex science of electronical gizmos and technological doodads. And to this day, the greatest minds of science and professors are still yet to come to a generalized consensus on how any of this kind of stuff works. It is not a particularly wise nor prudent path to argue with nerds about things that don't really matter. All physics and engineering aside, angry electro pixies come in two particular varietals. Positive and negative pixies come in the form of direct current, the cisgendered varietal of electronical pixies. Our second varietal is the flippy-floppy type of pixie. It changes back and forth. This particular pixie doesn't give two fucks about your pronouns. And the one thing that both of these have in common is that they are both angry. In any particular instance where there's a large amount of very angry things coming up to wreck your shit, it is important for us to know two things. How many angry things are we dealing with? And how angry are they? Science has a particularly poor track record of naming things to make any kind of sense. Amps was the science word that they used in order to name how many pixies are coming to fuck your day up. And volts, of course, is how pissed off they are. Going back to my favorite diagram. Here we have a negative and positive pixie receptacle hooked up. When they are closed and they both enter the Thunderdome, it turns into a big explosion. Thanks, Morgan. I can call you Morgan, right? We're friends. Can I call you MF? So, here we go. Our first electronical doodad. This thing right here is called a resistor. Resistors take electropixies, and instead of turning them into light, they turn them into heat. And by turning your voltages into heat, it can reduce the voltage, which is really good if you're
dealing with any of the other electrical components that will explode if they get too many volts. Resistors are used all the time to limit how much electricity goes to other components so that they don't catch on fire. And that is pretty much all they do. How much electricity these things can resist is called resistance, and it is measured in this Greek letter. I think it's Omicron Persei 8. This next part is where everybody starts throwing algebra at you like you want to do algebra in your free time. Nope, straight on to the next one. Here's our next electronical gizmoid. This is called a diode, and look, it's our old pal resistor. Because if I hook this diode up straight to a battery, it would just fucking explode. So from here on out, now we got this guy. This is called a current limiting resistor, which is basically an electronical doodad, which keeps our other one from catching on fire. What is a diode? A diode only lets electricity run through it in one direction. Seems pretty dumb and useless right now because this circuit is actually pretty dumb and useless. But they're useful for, if you plug the battery in backwards, you don't want to fry everything up. Diodes. We can always remember the diagram because the arrow points the pathway for the positive pixies. Next gizmotron's called the fuse. Now, volts of angry pixie is a pressure. It's how pissed they pressurizing the circuit. But some circuits, if we added way more shit, can actually suck juice out of the battery. Fuses are designed to explode if there's too many pixies flying around. They blow up so nobody else has to. Little semiconductor superheroes. Now this is our first complex new doodad. This is called a capacitor. You can find a million videos out there on how to make these things and how they work. But what do they do? Essentially, it's a tiny little battery. These things can store up pixies on them like that, and it'll actually store up to the same voltage your battery is. Now, the thing that makes this different than a normal battery is that these things are capable of taking all of that charge and getting rid of it that fast. If you did that to a battery, the battery would explode. Great. What the fuck's so useful about that? Capacitors can be used in a bunch of different ways. The first one's like a shock absorber. So if we had a bucket of water with a hole in it, we would get like a constant stream of water out. If we were just dumping weird intervals of coffee cups into this bucket, we'd still get a nice smooth stream. Because I know we haven't gotten into it, but there's radio waves. You probably listen to a radio once or twice. And what's a radio antenna? Well, it's a freaking piece of metal. So what happens is all this stuff's made out of metal. It picks up weird radio frequencies and noise from cosmic rays and all over the fucking place. So if you got a computer chip and here's an input on it, you're going to want to put a little capacitor on it to keep all the radio noise and Pornhub shit flying around in the air from getting into your computer and making it flip the fuck out. And this particular thing is called a decoupling capacitor because it blocks a lot of the noisy shit from blowing up your computer chip. In your old school cameras with the flash that would have to take time to charge up, there was a big honking capacitor in there, and they had a whole bunch of other widgets to jump the voltage up from your AAA batteries to like a lot of volts, and it would charge up this big capacitor to make that light go boom. But capacitors don't really do anything useful for the most part in battery circuits because basically it's like, I'm a copy you. It turns into a little battery, and then it's like, eh. But if we did have this circuit hooked up to a light, and then I cut the power from the battery, this charged capacitor would actually keep the battery going for just a little bit, and it would slowly die instead of immediately die. Which is probably why you've seen that somewhere too. So the shock absorption factor on your capacitor depends on its size, much like the bucket and the water. We'll say that this bucket is only rated for shock absorbing water dumps at certain levels. If you're barely drip dropping water in there, or you're dumping a whole fire truck in it, that's not going to work. So here we got a resistor and a capacitor. That's our radio and a speaker. What we've done is we've put the little knobs on here so we can change how many Omicron Persei 8s this resistor is dealing with. And by changing that, what we can do is effectively change the shock absorption of this capacitor here. Those low, mid, high, equalization buttons on your radio, this is basically all it is. By changing that value, it changes the amount of drippy drops flowing into your bucket. Oh, I forgot to bring up a really important point. This is like a DC battery type thing, but you know what we haven't talked about yet? Our flippy floppy pixies going back and forth from plus to minus. When capacitors handle AC, you know, this doesn't just charge up positive and this doesn't charge negative. It's flipping back and forth, so the capacitor doesn't know what the fuck to do. It's a complex thing that we'll get into later. It's called capacitive reactance, and that is the capacitor fucking reacting to that. Our next little guy is called a coil, but I like to think of it as a electromagnet. When pixies are flying through a wire, they make a little bitty magic magnetic field that's kind of goes outside of the wire. And if we coil that wire up, this magnetic field, so kind of like the capacitor, this thing is charging up too. They are typically called inductors. That's a fancy $12 word for coil wire that has a magnet field on it, but that's a science lingo for it. And there's an apparent flocculation of electricity that happens in these guys that I'm going to try and draw for you. It's a little complicated, but follow the bouncing dots. So as the pixies travel down the line and they make their first thing around the rosy, it first makes itties bitties baby's magnet field. But as they keep climbing the coil, the magnetic field starts getting bigger. And you know, the north and north sides of magnets don't want to stick to each other. And what you start getting as it keeps climbing up, you get new magnet fields. And look at how much garbage this is turning into. Magnetic flux? More like magnetic fucks. So it takes some time when the electricity guys are flowing through it for the magnetic field to finally stabilize into something nice and more presentable like this. All the while though, the pixies are having no problem running through that whatsoever. What is changing with this magnet field shit is how angry they are. They're running through it, but their anger level is temporarily flip-flopping up. So this has its own type of reactance. So a good thing to take away are two crazy flip out components that don't know what the fuck's going on all the time, are capacitors and coils. Fucking great news though is they freak out about the complete opposite shit. So if you have a circuit where you got one of these and it's flocculating up the pixies all crazy, you can actually add another one of these things and stabilize out the flocculation because they're polar opposites of each other. Capacitors store volts and coils store pixies. And this one likes the DC volts where it gets one from the other from the other side, so it can charge up just fine. But you send a flip-floppy pixies through it, it doesn't know what's going on, so it does its flocculations. These guys, they can't build up a magnetic field worth of fuck with flip-floppy pixies in them. If you send flip-floppy pixies through a coil, you'll basically get perpetual this garbage. Both store electrical power, but these guys will get on a DC and boom, it's almost like it doesn't think. So capacitors are kind of used to stop DC from getting through things when the AC guys can fly right through it, no problem. AC guys going through coils of stuff have a hard time getting through all of this garbage because it never stabilizes itself out, while the DC guys, yeah, you know, they're no big deal. So coils can be used to stop AC waves, and capacitors can be used to stop flocculations on the DC bit by being a shock absorber. It's getting to be about that time of the day, and of course I wouldn't be able to explain all of this to you in 4 minutes. Quick overview. We got two types of pixies, DC and flippy floppy guys. They come. How many are there is amps. How pissed off they are is volts. If we hook up a light bulb to a battery, boom, it turns on. This is a resistor. It turns electricity into heat to prevent other things from exploding. This is a fuse. These things designed to explode to keep other things from exploding. This is a diode. The arrow points in the pathway of positive pixies in order to keep you from plugging the battery in backwards and blowing shit up. This is a capacitor. It can be used as a shock absorber or for a temporary storage receptacle to make a big shit pile of electricity go blang. When you hook up DC to it, they charge just up like a battery, but when you put a flippy floppy pixies in there, they start freaking out and they come up with this new magic called capacitive reactance. Coils of wire are called coils. No shit. And they have this cool magnetic field thing. But it takes them a while when the pixies first start to turn this into this. And because flippy floppy guys are always going to have this going on, it's a backwards capacitor. Just trust me. Still got a lot of this book to cover, okay? So I'm probably going to have to make a part 2 because I'm not made out of free time and unicorn farts. If you'd like me to make a part 2, tell me. I'll make a part 2. But if you want to be a draconian smarty pants fuckface about it and tell me that I'm wrong about everything, I don't give a fuck what you think. Or don't. If you live in America, it's pretty freaking cold right now, so stay dry and don't die.